Welcome my friends to my YouTube channel. Now yesterday's lecture I have told about artificial satellite and its total energy, and I did few numericals related to this. And now yes, in today's lecture I shall going to discuss about escape velocity. Escape velocity. Okay. So escape velocity of a planet or a satellite. At first, the first question there arises, what is escape velocity? Okay. Now it is the minimum velocity with which an object or a body is projected so that it can leave the gravitational pull of Earth, or you can say or any other planet. Okay. So the minimum velocity with which a body is projected so that it can leave the gravitational pull of Earth or any planet, okay, is called escape velocity of that planet. Okay. So it is the minimum velocity with which a body is projected. It is the minimum velocity with which a body is projected so that it can leave the gravitational pull of Earth or any other planet Okay. It is the minimum velocity with which a body is projected so that it can leave the gravitational pull of Earth or any other planet is called escape velocity. Okay, now it can be shown that the value of this velocity depends upon the size of the planet. Okay, value of this escape velocity depends upon the size or radius of the planet. Okay, so how we can verify it? Okay, so in order to justify this, let us take a suitable example. So let us take the example of Earth. Okay, let us take the example of Earth. Okay. Okay, now suppose this is Earth. Okay, this is the center of Earth. Now suppose an object of mass m is located at a distance x from the center of Earth. Okay, an object of mass m is located at a distance x from the center of Earth. Fine. Now what would be the force of attraction between the Earth and the object? If this force of attraction we write F, so simply this is G, mass of Earth, mass of object upon x square. Okay, so this is the force of attraction between the Earth and the object. Okay, fine. Now what would be the amount of work done in taking the object by a small distance dx? At first we have to find it. So work done in taking the object, okay, work done in taking the object by a small distance dx. Okay, work done in taking the object by a small distance dx, what would be it? So if it is dw, this is simply f into dx. Okay, so this is simply g into m by x square into dx. Fine. Now what would be the amount of work done in projecting the object, say from Earth's surface to infinity, that is Earth to infinity, that is we have to shift this what would be the work done in shifting the object from the surface of earth to infinity? We have to integrate this expression within these two limits. So the result will be this: gmm is a constant, so it comes out r to infinity. This is simply x to the power minus 2 dx. So this is simply gmm. Okay, this is minus 1 by x. So if we neglect, if we interchange the minus, then this limit becomes infinity, becomes in lower limit, and r becomes upper limit. So this is the result, gmm by r. Okay, so this is the amount of work done to displace the object from earth's surface to infinity. Fine. Now if v be the escape velocity of the planet, okay, say ve be the escape velocity of the planet of mass m, so what would be the kinetic energy? The kinetic energy will be half mve square. Okay, here v is the escape velocity of the planet of mass m, so this is the kinetic energy. And now from work energy theorem, what we can conclude? Work done, this must be equal to kinetic energy. Okay, so what would be work? We find it gmm by r, and this is simply half m into v square. Cancels, so what would be my v square? That is simply 2 into g into m by r. Okay, now acceleration due to gravity at earth's surface, this is simply gm by r square. So what would be my gm? This is simply gr square. Okay, so 2 into gr square by r, so this is simply 2gr. Okay, so from which we get v, this equals to square root 2gr. Okay, so this expression clearly indicates that the escape velocity depends upon the radius of the planet. That means nothing but the size. Radius determines the size. So clearly the value of escape velocity depends upon the radius of earth. Okay, now if you want to calculate the numerical value of escape velocity in case of earth, so it is simple. So what is g? 9.8. And what is r? 6400 kilometer into 10 cube meter. Okay, so this is meter per second, and this is simply 11,200 meter per second. That means 11.2 kilometer per second. Okay, so this is the escape velocity of earth, and similarly you can calculate the escape velocity of other planets if you know the value of radius of that planet. Okay, obviously size will determine this. Okay, so this is what about escape velocity. Okay, now our next issue is that our next question or next task is to find out the force of attraction. We have to find out the um, uh, law of gravitation by using, say, Kepler law. By using Kepler law. Okay, law of gravitation by using Kepler law. Okay, that means by using Kepler law we have to show the law of gravitation. Okay, so let's proceed. So as usual, here we consider the simple circular orbit. For simplicity we consider the orbit to be a circular one. Okay, so here, okay, say this is the radius of earth and the satellite, or say Here we consider the sun and the earth, because we have to find out the force of attraction between the sun and earth, that we will show. So if we consider the sun, say, okay, okay, and the earth is revolving around the sun, we take this example, okay. So consider ms, this is the mass of sun, m mass of earth, okay, and r is the radius of the orbit, and v is the orbital velocity of earth rotating around the sun. That means this is r, okay. So here clearly the gravitational force, that must be equal to the centrifugal force due to the rotation of earth. Obviously this is the stability condition, that gravitational force of attraction between earth and sun is equal to the necessary centrifugal force due to the own motion of the earth around the sun, due to spin. So this is the orbital stability condition. So we can clearly write this is mv square by r, that means mass of earth, this is v, this is the necessary centrifugal force, you can give it c, okay, because the expression of centrifugal force is mv square by r, okay. Now m by r, if t be the time period of revolution, then we can put 2 pi r by t instead of v, no problem. So just simplify it, m upon r 4 pi square r square by t square, okay, by t square. Now we will use Kepler's law. What? For circular orbit, t square is proportional to r cube. So we can put t square equal to kr cube. So just substitute here. So m by r, this is simply 4 pi square r square upon k r cube. Okay. So r to the power 4, that means 1 upon r square. So 4 pi square by k, this is simply m by r square, okay. This is a constant quantity, that means centrifugal force, this is proportional to this term m by r square, okay. 4 pi square by k is a constant quantity, okay. This is a constant quantity, so centrifugal force, this term is proportional to m by r square, we can conclude it. And again the stability condition gives us that this force is equal to the gravitational force. So if fc is proportional to m by r square, fg is also proportional to m by r square. So give it a name, say 1, okay. And we all know that gravitational force is a mutual force, so that means this force is also proportional to the mass of sun, okay. Since Fg is a mutual force, it is always proportional to the mass of sun. So you can easily write Fg, this is proportional to ms, mass of sun. So give it a name 2. So what you can conclude from 1 and 2? Fg is proportional to m into ms by r square. So this is simply Fg, this is simply g into m into ms by r square. So this is the Newton's law of gravitation by using Kepler's law, okay. So fine. So with this lecture I have completed the central force and Kepler laws of planetary motion chapter. Now in our next class I shall going to discuss the gravitation chapter, Okay, gravitation chapter, and link of this video will be given in the description box. If you have any query, you can write it in comment section. Okay, so dear guys, kindly subscribe my channel to get latest updated videos. Okay, thank you.